Hi guys, this is the Module 5 semester review video. So in this unit, this was all about quadratics. We learned a lot of different things about graphing quadratics, how to solve quadratics. We also introduced complex numbers and I. So I'm just going to jump right into the examples. You can certainly write down some of the notes I have if you think they would be helpful, or if you want to put them on your note card, that's fair game as well. Okay, so in operations with I, when I multiply, I'm going to multiply just like I would any binomial. I'm going to take 7 and distribute it to both terms in the second complex number. So I've got 7 times negative 8 is negative 56. 7 times 3i is 21i. Okay, so now I'm going to do negative 6i times everything. So negative 6i times negative 8 is positive 48i. Negative 6i times 3i is negative 18i squared. Okay, so because I is defined as a square root of negative 1, when I square I, it is negative 1. So this whole term becomes negative 18 times negative 1, which is positive 18. So I'm going to combine now like terms. I'm going to put the real components together and the imaginary components together. So we've got negative 56 plus 18 is negative 38. And then 21i plus 48i is what? 69i. So there is my solution. We combine like terms, the real components, and the imaginary components. Okay. Because I is the square root of negative 1, remember we don't consider an expression simplified if there's a radical in the bottom, and I technically is a radical. So we're going to get rid of it by multiplying by the conjugate of the denominator. So here's your note up here about conjugates. Whatever real and imaginary piece are, I'm going to write that same exact thing, but I'm going to change the sign in the middle. So I'm going to do 4 minus 5i. Okay, and again, I'm just multiplying by 1, but it's going to change how things look. So we are going to distribute across the top. So I've got 12, 3 times negative 5i, negative 15i, negative 2i times 4, negative 8i, negative 2 times negative 5i is positive 10i squared. Okay, on the bottom, we're going to have something really similar, but this is difference of squares. So if you recognize that, the shortcut is it's 4 squared minus 5i squared. Okay. So now I'll do a little simplifying. So we have a couple I squareds in here. So this one's going to turn to negative 10. Negative 10 plus 12 is 2. And negative 15i minus 8i is negative 23i. On the bottom, I have 16 minus 25i squared. Again, that's negative 1. So I really have positive 25 plus 16, which is 41. And it's just a good idea to check, can I reduce any of this? But there's not a number that goes into all three of those terms. So this would be my simplified fraction. No i's in the denominator. Okay. Next piece was a lot of solving. Remember, we have 3 different methods of solving. We have solve by factoring, solve by completing the square, solve by quadratic formula. So I'm going to do one of each so we can see that. So this one, I'm recognizing I can factor out a 5 out of everything. So I'm actually just going to divide everything by 5. We're trying to get x by itself, so getting rid of the 5 right now is fine. So I now have 3x squared minus 2x minus 5. Equals 0. Okay, so I'm factoring. So I have a number that's not 1 in front, so I'm going to multiply. So I've got 3 times negative 5. So I'm going to treat it like this, and I'm going to factor normally. Numbers that multiply to be negative 15 that add to be negative 2 are negative 5 and 3. And then this is where I come in and reduce and bottoms up. So I'm going to divide by my 3, that leading coefficient. Okay, bottoms up with that one, it doesn't reduce, so I've got 3x minus 5. And this one, 3 over 3 does reduce to just x plus 1. Once I have it factored, now I set each factor equal to 0. So we've got 3x minus 5 equals 0, x plus 1 equals 0. So my solutions, add 5, divide by 3, subtract 1. So those are my 2 solutions to that quadratic. Remember, solutions correspond to x-intercepts of the parabola. Okay, this one, I'm going to use completing the square. The reason I'm suggesting that is I'm noticing it's not easy to factor. There aren't numbers that multiply to be 3 that add to be -6 that are nice whole numbers. And b is even. So I like doing the complete the square when b is even and the leading coefficient is 1, because b over 2 then is just a nicer number to work with. Okay, so I'm going to subtract c to the other side. And this is where I like to leave a blank for what I'm adding. So remember, completing the square is adding b over 2 squared to both sides. B over 2 is -3, squared is 9. Adding that will make this factorable. And remember, the number that goes here is always going to be whatever b over 2 was, which for us was -3. And then from here, I can take the square root of both sides. Remember, anytime you use square roots in the solving process, you have to remember the plus minus sign. And then we want to get x by itself, so I'm going to add 3 to the other side. So we got 3 plus or minus the square root of 6. So there's my solutions for number 4. Okay, number 5, I'm going to go ahead and use the quadratic formula. I notice I have a leading coefficient that's not 1. So if I were to factor out that -3, I'd be left with a fraction for b, so completing the square is a little ugly. Okay, so I'm going to set it equal to 0 by subtracting 4. So in the quadratic formula, my a is -3, b is 4, and c is -4. So we have x equals b squared, -b plus or minus square root of b squared minus 4 times a times c, all over 2 times a. Okay, simplify what's under the square root. So we have 4 times 3 times 4, 48. So I'm going to be left with 16 minus 48, which is -32. So here's where I'm at now. I've got x equals -4 plus or minus square root of -32 over -6. Okay, so anytime I have square root of a negative, we want to rewrite it using I. I also want to break down 32 and see if there's any pairs I could pull out. So actually, I'm just going to do this, make it a little easier. So 16 times 2 is 32. So that gives me a pair of 4s that I could pull out. And I'm going to pull out an I to take care of that negative. So now I have x equals -4 plus or minus 4i. And the number that's left underneath the root is 2, all over -6. Okay, so negative divided by negative, I can make this positive. Also, I'm looking for what could go into all 3 of these terms. So 4, 4, and 6 are all divisible by 2, so I'm going to go ahead and do that to simplify one last step. So this would be my solutions to this quadratic. If I'm getting complex solutions, it just means that my parabola doesn't ever cross the x-axis. Okay, last problem here, we're going to graph a quadratic. Remember, you will have a graphing calculator in your test, so you can always check your graph using that. So I'm actually going to do this part first, you guys, just because I haven't shown that to you. So axis of symmetry, it's one of the things I put in the notes at the top, but was x equals -b over 2a. So if we do that for this one, we're going to get -2 for the axis of symmetry. Okay. Vertex, how I get the vertex, I now know the x coordinate of the vertex, but to get the y, we're going to take -2 and plug it back in for x. So we've got -2 squared plus 4 times -2 minus 12. So we got 4 minus 8 minus 12. So I think we get 16 there. Sorry, -16. Yes, -16. Make sure I did that right. Yep. Okay. All right, so the y-intercept, remember, is always c. So we got 0, -12. The x-intercepts, we might be able to see this easily from solving, or I can check, is this easy to factor, which this one actually is. Numbers that multiply to be 12, that -12 that add to be 4 would be 6 and -2. So if we were to set that equal to 0, my solutions would be -6 and +2. So The zeros would be negative 6, 0, and 2, 0. Okay, this, because my leading coefficient is positive, it's going to open up, which means my vertex is a minimum. The domain of any quadratic is all real numbers. The range, because this opens up, the lowest point my graph will ever hit is the vertex, and the y-coordinate of my vertex is negative 16, and then it's going to go up forever. Okay, vertex form, I could complete the square to put it in vertex form as well, but I already kind of did the work that I needed to. Here's my vertex, and my a value is 1, so if I put this in vertex form, I'd have x plus 2 squared, and then minus 16. Okay, so you can complete the square to get this, or you could do the negative b over 2a to get this as well. Okay? All right, so now we're going to graph it. So my vertex is at negative 2, negative 16. I'm going to go by 2's to make this fit. So negative 2, negative 16, 1, 2, 3, 4, 5, 6, 7, 8 if we're going by 2's. Okay. And my y-intercept is negative 12, so there's negative 16, negative 14, negative 12. And we're mirroring over that x-axis. Okay, and then our x-intercepts are 2 and negative 6. All right, and this looks a little maybe more squished than normal just because I'm going by 2's, you guys, but there are my points. If we're going by 1's, 2, using the pattern would be easy, where I go up 1 over 1, up 3 over 1, up 5 over 1. But I already had plenty of points just from this information here. And that's enough to answer my question and get the graph. Remember, we typically do want 5 points. Vertex, y-intercept, and zeros are a great 5 to have. Okay, that's it for this video.